Hello and welcome to this Altair AI Studio tutorial. In the video on model selection, we left off with a cliffhanger about optimization. Now we don't want to leave you hanging any longer, so here we will show you how parameter optimization can be easily achieved in Studio. So let's get started. We will repurpose the process created in the model selection tutorial, which you can see displayed here. If this is the first video from our series you're watching, then make sure to download the process and the data used here from our website. In our data loading via a process video, you can see how to import the processes and the data. Now let's go back to parameter optimization and our process here. In the cross-validation, we have a decision tree model for which we want to find the optimal parameter settings. We will optimize our accuracy by identifying the best combination of the criterion for splitting the attributes and the minimal gain. The criterion selection defines the criterion by which attributes will be selected for splitting, and the minimal gain governs the threshold which we are requesting in order to allow the next split. The optimization is done via one of Studio's optimized parameters operators. We will use the grid version. Before we do that, let's first save the process in our repository as 07 parameter optimization. And while we're doing housekeeping, let's disable the compare rocks and the multiply operators since we won't need them here. Now let's just cut the cross-validation out, connect the optimization instead. Then paste the cross-validation as a whole into the optimize parameters operator. After connecting the input and output of the cross-validation operator, we are now ready to define the parameters we want to optimize. So, let's select the Edit Parameter Settings wizard. As mentioned, we want to optimize the model's parameters, so we select the decision tree first. The second step is to select our first parameter, the criterion, which then populates the rest of the dialog. We can leave all the defaults as we just want to loop through all the criteria available. We see information displayed that we are now creating 4 combinations, which is intuitive given the number of criteria chosen. The second parameter we want to select for optimization is the minimal gain. This parameter controls how soon splits are made, so the lower the threshold value, the larger the tree grows. Now that the dialog has populated further, we can define how we vary the criterion. To determine if 0.1, which is the default, is a good choice, we will test with higher and lower values through 100 steps. We have configured 404 parameter combinations, and given that we have a 10-fold cross-validation in each loop, it means we are really producing over 4,000 decision trees. As you can imagine, this can become pretty computation and runtime intensive, so you want to be careful about selecting the number of parameters and the granularity of your optimization. Now we can close this dialog, but before we start the process, which will deliver us the optimized performance and the parameters combination used for that, we will add a log operator so we can take a bit of a closer look afterwards about what happened during the optimization. The same can be performed by simply checking the log all criteria box here, but we will still use the log operator for a quick intro to it. We could specify a file name to create a file dump of the log, but we just want to have a quick look at the log. So let's move on to editing the list of content for logging. We certainly want to see the parameters we are optimizing for, so let's add gain and criterion first. Be careful to select the correct instance of the decision tree here. The one with the number 2 in brackets is the one in our currently disabled compare rocks operator. Further, let's add an iteration counter. Of course, we want to know each loop's performance, so let's add that as well. For both of the latter 2 list items, be very careful to retrieve the information of the cross-validation, and not from the model or even the performance operator, because if you do that, you are logging values inside the cross-validation, which are generated using the subsets in our 10-fold cross-validation. Okay, so we apply a count to the cross-validation, and then we log the performance value of the cross-validation. Let me repeat this. Don't log the performance of the performance operator, as that will only output the value of the last fold of each iteration going through the cross-validation, but you are usually only interested in the average performance over all folds of the cross-validation. Now, let's run the process. Nice. Our performance is roughly 85% with our optimized parameters, as shown here. As you can see, the minimal gain is close to the default of the decision tree, which was set to 0.1, but the criterion accuracy seems to yield a higher accuracy. To find out more, let's take a look at the log. We can see that iterations were performed for each combination of gain and criterion, and the log shows each performance. If we briefly create a chart displaying the parameters we varied and the performance for the different combinations. In that case, we see that it is not helpful to define a minimal gain parameter higher than 0.3. And if we zoom in on the area with the highest performance, then we see that the accuracy was clearly the best split criterion to use. The next tab shows the same logs generated automatically by our optimized parameters grid operator. All right, this concludes our tutorial on parameter optimization.
Make sure to check out the model selection module and the one on automation, which shows you an optimization using more than one model. Thank you very much for watching.